In this video, I am going to explain the three basic logic gates, which are the NOT gate, the AND gate, and the OR gate. Let's start with the NOT gate. The NOT gate is a type of gate that takes one input and gives us one output. In fact, it is drawn like this. This single wire here is representing the input, while this single wire here is representing the output. I am going to label the input with letter A and the output with letter X. To understand what a logic gate does, we have to draw a truth table. The truth table will show the input combinations and the respective outputs for those inputs. In this case, since there is only one input, the inputs in this truth table are going to be either a 0 or a 1. So we have two inputs in all. The output is going to be X. Now the NOT gate works like this. If we give it a 0, it will give us the opposite. It will give us 1. And if we give it binary 1, it will give us back binary 0. So in other words, a NOT gate acts like an inverter gate. In order to write or represent a NOT gate with Boolean algebra, we can either use the name of the gate itself, so we always start from the output, X equals, and we write down the name of the gate, in this case, not followed by the input, so X equals not A. However, this method is not very practical when you are working with Boolean expressions. So it is better if we use the Boolean algebra symbols, which for the NOT gate is the bar notation. It's a small line on top of the letter. So in that case, we write it X equals A, and to indicate that this is not A, we write this line on top of it. Sometimes we also use the apostrophe. We write X equals A apostrophe, and this apostrophe represents a NOT gate. Personally, I don't like this notation, so I prefer if I use the bar notation, this one. Okay, so for this for these videos, I am going to use that method, that notation. Now let's do the other gate, the AND gate. And an AND gate takes two or more inputs and always gives us one output. So if we have to sketch the symbol of an AND gate is drawn like this. It always gives us one output, which I am labeling using letter X. And in this case, I am going to give it two inputs, which I am going to label A and B. I repeat that an AND gate can take a minimum of two or more inputs. Let's do the truth table. We have A and B as inputs and X is the output. When we have two inputs, it means we have four different input combinations, which are 0, 0, 0, 1, 1, 0, and 1, 1. If you convert these to binary, actually, if you convert these binary numbers to decimal, you will notice that these represents the numbers in decimal 0, 1, 2, and 3. Now the outputs that the AND gate will give us in this case are these 0, 0, 0, and 1. And if you notice the output, you will note that an AND gate will give us a 1 only when all the inputs, in this case when A and B, are both 1. Whenever there is a 0 in the inputs, it gives us a 0. Hence, X in this case will be a 1 only if both A and B are 1. If we have to write this in Boolean algebra, we can either use the AND word, so X equals A and B. If we so this is AND. If we are using, however, this to work out Boolean algebra questions, it's better if we use the Boolean algebra symbol, which is the dot. It's shorter. So X equals A dot B. Sometimes if you write X equals AB without the dot, it will be accepted as well. However, it is better if you stick to this method and always use the dot. Let's now do the last gate, which is the OR gate. Like the AND gate, the OR gate takes 2 or more inputs and gives us only 1 output. So if we start by drawing the symbol of the OR gate, it is drawn something like that. I'm going to give this OR gate 2 inputs, A and B, and 1 output, which is X. Let's do the truth table. We have 2 inputs, so A, B, and 1 output, X. It is very similar to the AND gate. So I mean, we can copy the inputs of the AND gates. They are the same. 0, 0, 0, 1, 1, 0, 1, 1. There is a trick how to write down these inputs always in order, especially when the number of inputs is larger than 2 bits. I will explain this in another video. The output for the OR gate will be 0, 1, 1, 1 in this case. And if you notice what's happening, basically the OR gate is giving us an output of a 1 whenever there is a 1 in the inputs. So basically, in this case, X is 1 when either A or B is 1. Obviously, if both of them are 1 as well, the output will be 1 as well. If we have to write this in Boolean algebra, we either write it using the English word, so X equals A or B. Otherwise, it's better if we use the proper Boolean algebra symbol, X equals A, and for OR we use the symbol plus B. So my suggestion is that you stick to that notation.